Hi, all my YouTube viewers. It's Crystal here. I'm just making this code review. I want to let you know that it is the second code review that I've made because the first one didn't work. I'm having problems making videos on my laptop. I can't do it with my Xbox because the audio is corrupted. So I'm having to use a free online um, video recorder, so I'm hoping that it'll work on the second time because I've been spending all day long just trying to make videos. So what we're going to talk about is the Keras NLP, whereas Keras NLP is a library where you can do natural language processing in Keras. So the first thing we're going to do is we're going to make a Jupyter notebook and a Google Colab, which is a free online Jupyter notebook sponsored by Google. And then what we're going to do is we're going to install the libraries of Keras Core and Keras NLP. We're going to, after we've installed the libraries that we need, we're going to import the libraries that we need, being NumPy, Pandas, TensorFlow, Keras Core, Keras NLP, sklearn, Seaborn, and Matplotlib. And you can see that TensorFlow is version 2.16.1 and Keras is version 0.9.1. And so TensorFlow goes through a lot of revisions, so you need to stay on top of the revisions because you can do something now and in 6 months from now it's not going to work because the code could be deprecated or they could have changed the code. So after we do that, then what we're going to do is we're going to use TensorFlow to set the seed to try to hope that you get a good, reliable prediction. And then after we use TensorFlow to set the seed, then we're going to load a CSV file that we got off of GitHub, which is tweets. So after we loaded the CSV file, we're going to convert it to a data frame using pandas. And then what's going to happen is you've got an ID column. Well, pandas data frame, every row of data is automatically indexed, so you don't need the ID. So what we're going to do is we're going to drop the ID because you don't need it. So you're just going to have a label and a tweet. So your label is your target and your tweet is your Y variable. Now what we're going to do is we're going to use Seaborn to analyze the label, and you can see that there's a very large class imbalance here. So we're going to do a value counts on the label, and you can see you've got a lot more zeros than you do one. You have two classes. Okay, and then so what we're going to do is we're going to, after we've done that, we're going to process the tweets. So the batch size is 32. The num training examples is the first column of the shape of the DF. Training split is 80%. Val split is 20%. Steps per epoch equals int num training examples times training split floor batch size. It's going to be 2 epochs because it takes a really long time to train the data in Keras NLP. And so we're going to set up auto equals tf.data.experimental.autoimmune. So we're going to set up our X and our Y variables. Your X variable is your tweet and your Y variable is your label. And then we're going to use sklearn to split the X and Y variables up into training and validation sets. So now we're going to define the model, which is a pre-trained model called distill-BERT. So the preset equals distill-BERT base in uncase. So the N means it's in English. So now we set up our preprocessor, and then after we've set up our preprocessor, we're going to set up a classifier. After we've set up the classifier, then we check the summary of the classifier so you can see that it will make a little graph of that so you can see what everything in the classifier is doing. And now what we're going to do is we're going to train the model. So you compile the model, and the loss is going to be sparse categorical cross entropy. The optimizer is going to be atom. The metrics is going to be accuracy. And then we're going to train the data into the model. So history equals classifier dot fit, X equals X train, Y equals Y train, batch size equals batch size, epochs equals epochs or 2, validation data equals X val, Y val. So we're going to let it train the data for 2 epochs, and it takes a really long time to train the data, and that's why we only have 2 epochs. So after we've trained the data, then what we're going to do is we're going to create a graph, so you can see your validation, so you can see your loss and your accuracy. And then we're going to set up the predictions. And don't ask me why, but when we did our predictions, predictions had 2 columns of data. So I had to make a decision. So I used column data number 1. So here's your predictions. And then what we're going to do is we're going to use Seaborn to actually analyze the prediction, and you can see that there's a very large class imbalance. We're going to check the accuracy of the prediction, and it's 96%, and the confusion matrix has 265 ones and 191 zeros that should have been ones. And so basically what has happened is this Keras NLP pre-trained model works slightly better than the bidirectional LSTM. So it's entirely up to you what you want to use. Do you want to use the pre-trained model, which is BERT, or do you want to use the Keras, or do you want to use the bidirectional LSTM? One thing that I can say, it's going to be hard to do it if you are entering a Kaggle competition, because when you enter a Kaggle competition, the internet has to be turned off. And if the internet is turned off, then you won't be able to access this pre-trained model. So that's just something to think about. So I'm going to go ahead and close this video because I've had a lot of problems making videos this morning. And so I'd like to thank my subscribers for watching this video, and I look forward to communicating with you in the next video.